Good morning, everyone. Good morning, Sachin. In today's class, we'll have a short class today because I'm busy with some work at university. But we'll finish one topic. We'll quickly write so let me just we'll begin the class today. We're not going to wait for too many people. So how many people are there? 24. Okay. So we'll start the class. They can join. So I hope that the screen is visible. And let me just kind of give you first an algorithm. Yeah, thank you. So let me just first kind of give you an algorithm, a bisection method, which we did yesterday, just to formally complete the topic. So like it's though I'm not an expert to write. I mean I don't know exactly the terminologies and the way an algorithm is written, but I'll just probably write some steps here. So first you obviously you begin, and then you will read some values. So you read x1 and you read x2. These are your hash means comments. So these are your initial assumptions. Okay, then you also read some value epsilon. So this is the error acceptable. Or acceptable error, whatever you want to call it, in the when you write the code. Right? Then you start. Then you say that okay, while x1 minus x2 is greater than epsilon, so the entire code will run. Whatever lines I'm writing below this, that code will run so long as mod of x1 minus x2 is greater than epsilon. So then you do the following. So do set x3 as x1 plus x2 divided by 2. The next step is if fx1 into fx3 is less than 0, then you set x2 as x3, because then the root lies between x1 and x3 and you have to discard x2. So automatically x3 will now become x2. Else, if this is not the case, then you will set x1 to x3, right? Because if x1 into x3 is greater than 0, that means the root lies between x3 and x2. So the next one becomes x3, and then it's basically that your if will end, and then your do will end, and then you will just write that then then basically you will write that x3 is your. You can also put put another statement over here that while mod of x1 minus x2 is greater than epsilon and fx3 is also greater than epsilon, or you can take some other epsilon 1, this loop will continue. But I think this one condition is enough. Okay. Now the question is, how will you choose epsilon? Okay. So that the question is how to choose this. What will be epsilon? So that will depend upon the problem. Suppose I say that find me the solution which is correct up to 3 decimal places. So 3 decimal places would be, suppose you were searching for a root between 2 and 3, and I said 3 decimal places. So then you will stop when you will have something like this. You will have x x x, suppose 4 5, and on the other side you have x x x, suppose 5 3, right? So then these 3 decimal places are exact. So you really don't need to worry about what is happening here. You will report the root as 2.xxx, right? So if this is the case, if you subtract these two, you are going to get a number which is at least of an order of 10 to the power minus 3, right? Or so you can safely choose this to be of an order of 10 to the power minus 4, something like this. So that you are assured that what the desired accuracy maintained. Or you can also keep it to be 10 to the power minus 4 would be it, because if you take 10 to the power minus 3, then you will see that this decimal value will be 10 to the power minus 4 order, of course. So at least go to 10 to the power minus 4. That is it. So अगर 3 decimal है तो 10 to the power minus 4 ले लो, 4 decimal पूछ रहा हूँ तो 10 to the power minus 5 ले लो. That is what. So whatever decimal I ask, you just take error to be just one more numeral in the negative. I say find me the root correct up to 5 decimal places. So your error will be 10 to the power minus 6. That is it. Basic. Come to. Okay, so this is basically the algorithm. Somebody sent me a message that he or she had written an octave code. It would be better that we discuss these things in the class only.
Yes, sir. It was me.
Yeah, but okay. What's your name?
Swastik, sir.
Swastik. So you can send that to me on mail, your code, because it was WhatsApp, so I couldn't really open much of it on the phone. So you can send it to me on mail and look into it. All right. Okay. So of course we'll do. So once all these 4 will be over, we'll just sit one day in the class and we'll write the codes for all the 4 together. Right? MATLAB codes for all these 4 together. Okay. So so then the next method that we have to study today. Somebody wanted to enter the class. The person entered. The next method that we are looking at is false positioning. So yeah.
So what does endif and end do?
Means basically what I mean by this is that this if loop is ending, and then end do means this do thing is ending. So basically the while loop is ending here. So end do means the while loop is ending, end if means that the if loop is ending. Basically that's what I want to do. I don't know whether it's the correct way to write it or not, but I just wanted to show. So here the if loop ends. So if if this, then if else loop, basically if else ends, and then here is your while ends. You don't really need to end while, so while automatically gets abrupted, but I just wanted to write it that it's all ending here. And I wanted to say that if will be inside the while, so that's why I wrote end if, and then no need to write it if it's not there in the terminology. I just wanted to show that. Okay, this is what it is. Okay, so nothing really too deep in this. You can just write a code while लिख के कर लेना, of if this, then this, else this, and then automatically while end hoga, and then you just print the value for it. Next is false position. Now, false position method is the second method that we are doing to solve these nonlinear polynomial or transcendental equations. And this method, though bisection method converges always, but it is a slow convergence. And it is said that false position method is slightly faster. It also always converges to a root, but it is faster than bisection method. So bisection method will always give a root, but it converges slowly. Okay. False position method it is also known by different methods. It's called as regular falsi method. In some books you'll find it as regular falsi. And it can also be called as method of linear interpolation. Method of linear interpolation. This is the false position method is considered to be faster than bisection method. Okay, and as I said while writing, it is based on linear interpolation. So we'll look into for this I'll give you a derivation, but we don't really need to do derivations all the time. But I'll give you, because it is using a term called linear interpolation. So that's why I want to give you a small derivation of the entire process so that you have an idea of what I mean when I say linear interpolation. So let's see how this function works. Okay. So you have some this thing, some effects. Just like this, effects, and let's say that it goes like this. Okay, so this is actually the root, right? This is where we want to be, but let's say that in our wisdom we chose one x1 here, and we chose one x2 here, like same as bisection method. So this point is x1 fx1, okay, and this point is x2 fx2. Okay. So if you do if you do the product of fx1 into fx2, then it will be a negative quantity, because you can see that one lies below the x-axis. Sorry, below the y-axis. Below the x-axis. So it's a negative value, and one value lies above the x-axis, so it's a positive value. So the product is negative. So one thing is similar to bisection method. At least the start is similar, that you will check for fx1 into fx2, and that should be negative. Then the root lies between them. Then if the root lies between them, then in bisection method we used to take x3 as x1 plus x2 by 2. So we used to half the interval every time, right? But in this case, what we do is, as I said before, we do some kind of a linear interpolation. So what do we mean by that? So we take this point, let me make it with another line so that color so that it becomes clear. So we take this point and we take this point and we draw a straight line connecting these points. So then when we draw a straight line connecting these points, wherever this line cuts the x-axis, that becomes the next point for us. So this point where it cuts will become x3. So this point here becomes 0, right? So it so happens that you come very close to the root. So you can clearly see that you could just draw a line and you'd probably be coming to the root, closer to the root much faster. So that is what it is. We find this x3. The question is, how do we find this x3? And once we find this x3, then we obviously find this point, which is x3 fx3. And then you again do that fx1 into fx3. If it's less than 0, then the root lies between them. Otherwise, the root lies between x3 and x2. And then you proceed the same way. So let's see how we find this x3. That's important. So how do we find this x3? It's a very simple thing. It's a straight line. So let's say that we take 2 points, which is x3 0, and we take point x2 and fx2. ये वाला point ले लिया और ये ऊपर वाला point ले लिया. So then slope of this line tan theta is fx2 minus 0 divided by x2 minus x3. This is tan theta. Then if you take points x3 0 and x1 and fx1, so you take these 2 points, then your tan theta is going to be fx1 sorry, let's not take this. It will give you you have x3 at 2 places. Let me just do it in such a way that the x3 is at only 1 place. So let's not take this point. Let's take this point. So this is fx2, x2 here, let us take x1 and fx1. The initial point. So then this will becomes fx2 minus fx1, x2 minus x1. So that x3 comes only once, so that we can get the value easily. Right? Of course, you could have taken x3 0 and x1 fx1 also, but then x3 would have come at 2 places. You have to interpolate it. So now, if you look at it, these 2 things should be equal because these are points on the same line. So the slope should be same. So if you put them equal, so fx2 divided by x2 minus x3 equals fx2 minus fx1 divided by x2 minus x1. So if you now solve for x3 in this problem, you can see that x3 is here and everything else you already know. So you can say that x3 will be basically x1 fx2 minus x2 fx1 divided by fx2 minus fx1. Okay. So this is what your x3 comes out to be. So in general, if you have to run it to ith iteration, sometimes people say that you can write it in terms of x I plus 1. You don't really need to write it. You can always remember this formula. So now this is your x3, and then you check the same x1 into x3. If is less than 0, then the root lies between them, and then you replace. And then so basically, the only difference between bisection method and forest position method is the manner in which you're calculating x3. Okay, and then the entire process remains the same. So we proceed like this only. So the the method follows like this. First step, choose x1 and x2 such that fx1 into fx2 is less than 0. This will ensure that the root lies between x1 and x2, right? Then of course you also choose sum epsilon. Right? Second step, find x3 as x1 fx2 minus x2 fx1 divided by fx2 minus fx1. So the formula becomes slightly more complicated because in bisection method what you were doing, you were simply writing x3 as x1 plus x2 divided by x2. Now you find this x3, and then on the third step you say if fx3 is 0, then x3 is the root, right? Else if fx1 into fx3 is less than 0, then obviously the root lies between x1 and x3. So then you replace x2 by x3, and your new interval that becomes x1 comma x3. Else if x1 into x3 is not less than 0, then obviously replace x1 by x3, and then your new interval that becomes x3 comma x2, and then you continue steps 1, step 2, step 3 till your required accuracy is obtained. Okay. Required accuracy is alright. So this is basically the method to evaluate the root using false positioning method. The only difference is you are not calculating x3 as x1 plus x2 by 2. You're calculating x3 by this complex looking formula. So you can try to solve one small problem. I'll do some steps, and you can just go through it, and that will be the end of the class today. So we'll just look into one of the problems. So the algorithm for this is simply the same. So like if you look at it here, the algorithm for it is the same except that only this line will change. Everything else is the same, right? So this will just become x1 fx2 minus x2 fx1 divided by fx2 minus fx1. That's all. So if you change only this line, the algorithm would be that of the false position method. Let's look at a problem. So you have x cubed minus 2x minus 5 equals 0. And I say that one of the roots of this equation lies between 1.75 and 2.5. Okay, find that. So fx1 you will evaluate, and that comes out to be minus 3.1406. I have this problem solved. Okay. And then you calculate fx2, and fx2 is 5.0 625. So you can see that fx1 into fx2 is less than 0. So obviously a root lies between these two. I've given them. So there is no need to check, but you can always start like that. Then you calculate x3, which will be x1 into fx2 minus x2 into fx1 divided by fx2 minus fx1. If you do this calculation, you will come to a value which is 2.018. Now you calculate fx3. If you do that, then that fx3 comes out to be 0.810. So now you can see that fx1 into fx3 is less than 0. Is this condition satisfying? No. This condition does not satisfy. That means what you will do is you will replace x1 by x3. Basically, this is what is happening. So fx1 into fx3 is not less than 0. In that case, you come here and you replace x1 by x3. So new interval becomes x3 and x2. So now your new interval becomes 2.0187 and 2.5. So now this is your x1 and this is your x2. Okay. So first iteration is over. Second iteration. So I'm just going to do one more iteration and then we'll just probably end the class because I have some work. But you can continue this way and I will give you the correct answer also, so that when you try it, you should be able to get it. All right. So now if you calculate, so now we are starting the problem with x1 as 2.0187 and x2 as 2.5. Okay. So now if you calculate fx1, you will get the value to be what was earlier, 0.8109. And then if you calculate fx2, then you get 5.625. You need these values because these will be used in calculating the x3 value. So now you again calculate x3, which is x1 fx2 minus x2 fx1 whole divided by x2 minus fx1. So when you do this, then your x3 comes out to be 2.0793. Okay, so then you calculate fx3 and then fx3 comes out to be minus 0.162. Okay. Now fx1 is fx1 into fx3 less than 0. What is fx1? fx1 is minus 8.109. fx3 is minus 1.668. So this is not true again. So that means replace x1 by x3. So then now your new interval becomes, what was x3? x3 was 2.0793 and 2.5. So now this becomes your x1 and this becomes your x2, and then you come to your third iteration. Okay. So if you do these iterations, you will see that after some iterations, and I'll tell you how many iterations, 1, 2, 3, 4. So after your fourth iteration, this is the fourth iteration, you will convert, so there will be a fourth iteration, and then you can also do a fifth iteration, and then you can also do a sixth iteration, whatever. After this iteration, you will see that one of the values of x, which will not really change, it will be 2.0945 something. So if I'm asking you find out the solution correct up to 3 decimal places, then you will see that you're getting something like this again and again. And so the solution for you would be this. You basically get this answer. So 2.094. You can check this by solving this problem again and again. Look, you can do these iterations and you can see that this is the answer. Right? You can try another problem. I can give you a problem and you can try that problem as an exercise problem. Okay, so let me just say cos x minus 3x plus 1 equals 0. I'm saying find out the solution which find the solution correct up to correct up to 3 decimal places. 2 minutes. Correct up to 3 decimal places between 0 and 1. So that is the, so you find that out. और इसका आंसर जो है, इसका आंसर होगा 0.607. I am giving you 4 decimals. So okay, so if it is 3 decimals, then the answer is 0.607 basically. You should not write 7. We just erase it. So this is it. Okay. So you can try this problem. You first try the problem that we were doing. You will converge to this value 2.094, and then you try the second problem. You will converge to a value 0.607. Correct. Okay. So do this. This is regular falsy method or false position method. In tomorrow's class, we'll do another method, which is going to be a secant method. Holy is coming, so we'll quickly do it. That will also be a short class. It'll just be an algorithm, and we'll solve a problem. And then maybe we can just finish this entire unit tomorrow by taking the 1 hour class in which we'll do a Newton-Raphson method also. So we'll finish it, okay? And then when we meet post-Holy, you can write codes for this, see the number of iterations, how they are decreasing, and then we'll also look into the pitfalls of these methods. Pitfalls meaning what are the shortcomings? Like yesterday, Abhi had mentioned that what will happen if you choose 2 routes, which are far away from both the routes. So we could see that bisection method would not really work there as effectively. If there was only one route, then we have a problem. So long. So like that, we'll also look into the pitfalls of some other methods. We're not really interested to see the pitfalls of bisection and secant method because they are pretty false position method, because we know that once we know the correct interval, we will definitely converge to a root. But we'll definitely see the pitfall of one of the methods which is considered to be the fastest among all these 4, Newton-Raphson method, and what are the problems there actually. Okay, so that's it. Thank you, and I'll see you tomorrow in the class. It will also be in the online mode. Okay, all right, bye.
Sir, isn't
Thank you, sir.
tomorrow a holiday?
Yeah. No, not tomorrow is not a holiday. Only the day you play Holi is a holiday. So technically, there is. It's not a holiday tomorrow. It's a restricted holiday, but not a holiday. So we'll have a class, right? And it will be. हाँ, कौन बोल रहा है? क्या बोल रहे हो देवांशु?
No, sir, no.
आवाज नहीं आ रही. चैट में लिख दो जो लिखना चाह रहे हैं. देवांशु चैट में लिख दो जो बोलना चाह रहे हैं. अच्छा, नथिंग सर. ओके देन, बाय बाय, सी यू, गुड डे.